In this video, we're going to meet the first of several theorems about polynomials. As you may recall from a geometry class, a theorem is a mathematical statement that we prove based on other mathematical statements. Up until this point in the course, we've been primarily concerned just with processes and procedures and learning a few definitions. So this is the first theorem that we're actually going to prove in this class. To a really great extent, the proofs of theorems are what the actual work of mathematics focuses on. So at this point, when you encounter a theorem that we do actually prove, your main job is to try to follow the proof. So follow along, take notes on the proof, but the best thing that you can do to study something like this is to take a little time later on to read through your notes and then put them away and see if you can reconstruct the proof without reading it directly. Right? That's one good way to see if you really followed the logic of the proof. Don't try to memorize it. Try to understand the logic so that you can explain it again. So this theorem is the remainder theorem and gives us one of the reasons that a person might actually want to divide polynomials. Let's first understand what this says. This theorem says that for any polynomial and any number, we can find another polynomial, call it q, and another number, call it r, so that we can multiply the binomial x minus our number k by the polynomial we found, q, and add in the number r, and that gets us back. Right, so this says if I give you p and k, you can find q and r. And furthermore, when you do that, r is the number that you get when you plug in k to the polynomial p. Okay, how can we do this? And why is this called the remainder theorem? Well, we can do this using long division. If we take p of x divided by the binomial x minus k, well, we get some quotient. Q of x can be our quotient, and we get some remainder. R can be our remainder. Now, when we do polynomial division in general, the remainder is another polynomial. But the degree of the remainder has to be less than the degree of the divisor. Our divisor is x minus k, which has a degree of 1. Now, the only whole number less than 1 is 0, so the remainder has to have a degree of 0. Degree 0, that means it doesn't have any variables at all, so that means that the remainder must be a number. Now, to see that that number is what we get when we plug our k into p, well, if we plug our k into p, that's, well, we're going to plug k into q, into x minus k, and r is just a number, so it just sits there. But then, well, k minus k is 0. So whatever this is, and this is some number, we have some number times 0 plus r. Well, any number times 0 is 0. So we just have 0 plus r, which is r. So that shows us that if we have any polynomial and any number, we can find the q of x, another polynomial, and the r, just the way the theorem says. So this little box shows the end of a proof. Because usually after we finish proving something, we're going to want to do something with it. And what about this theorem? Right, now we know that, well, we can do division. We knew that already. And the remainder is going to be what we get when we evaluate the polynomial. I mean, that seems like it might give us a useful way of checking our division, but at the moment, just plugging a number into a polynomial sounds like it's a lot easier than that whole long division process. So at the end of the day, so what? Why on earth would we ever want this remainder theorem? Well, it turns out that there's a much easier way of doing polynomial long division for certain kinds of divisors. And that's the main thing we're going to focus on in this section.